Hello students, and welcome back to Graphs with Sir's classes, and we'll be continuing with polynomial graphs. We'll be generalizing the graphs which are of the form, or rather we'll be generalizing the graphs of the functions which are of the form. Let me just write it here, changing ink. Right, we'll be generalizing graphs of the function x to the power 2n minus 1, and this is fx equals x to the power 2n minus 1. These are the graphs we'll be generalizing about, and write down the properties first. Now this is an odd function. The function given by fx equals x to the power 2n minus 1 is an odd function, is an odd function. So its graph is symmetrical about its origin. Graph is symmetrical about the origin. Now note that first let me explain to you what's happening. We'll note that the graph with the higher power, I'm talking about y is equals to x to the power 5. Note that before 1 it bulges out more than the graph with the lower power, that is y equals to x cube. Can you just note that this is before 1 that it bulges out, and after 1 the graph with the lower power bulges out and the graph with the higher power becomes more constricted, as was the case with the last graphs that are y equals to x to the power 2n. The trend is basically the same, and I'll just make you write the properties informally. Okay, let's just write it down formally what we are about to do. Just rub a part of this, and just rub a part of this so that I can write. So write down number 2 is that when x belongs to 1 to infinity, x is less than x cube, less than x to the power 5, less than ... and when x belongs to 0 to 1, it's just reversed as we just saw. This is greater than x cube minus x to the power 5 greater than ... Now when x belongs to minus 1 comma 0, same as this one, we'll have x is less than x cube, less than x to the power 5 ... and when x belongs to minus infinity to minus 1, we have x is greater than x cube, greater than x 5 ... So this is the general trend as mentioned, and just please note the trends. You know what, if you can visualize what's happening, then there is no problem in distinguishing which is which if the two graphs are given side by side. There is actually no problem distinguishing. What is happening you will have to understand, and then you can put it in words as I have in these postulates, which are again very important. Right, so we'll talk about rational functions in the next video. I'll see you there. Thank you for watching.